So in part 4 of section 3.1, we talk about combining functions together. So essentially, if you're given two functions, f of x and g of x, so two different functions, then the following definitions exist. In other words, we can sum or add those two functions together. So the notation says in parentheses f plus g of x. So it's f plus g of x. So again, it does not mean to multiply by x. It means of x. That's the variable we're talking about. So it simply means that I can take f of x and add g of x to it. I can do the difference, which would be f minus g of x. That's equal to f of x minus g of x. So if I have two functions, I can subtract them. Well, if I can add them and I can subtract them, can I also multiply them? Sure, that's the product definition. So f times g of x is equal to f of x times g of x. And I'm going to stop right there. Those three, we're going to talk about the domains. So the domain of the sum, difference, and product, the plus, the minus, and the times, is simply the intersection of the domains of f of x and g of x. So at intersection, you would simply go to the number line, graph each of their domains, and then take a look at where they overlap. What about the difference? So the quotient, not the difference, the quotient would be f divided by g of x. So that's f of x over g of x. So the same thing is true, but we have to tack on the fact that g of x can't equal 0, but we still have the intersection of the domains, so still true. So I know that we've been doing a lot with domains today, and you're going to see that on the homework with these types of problems also. So let's do an example of that and also talk about their domains. So we're up to example 5. Big section, there's a lot in it. So example 5, our two functions that were given is f of x is equal to x minus 4. G of x, the second function, is 2x squared minus just 2x squared. So again, this is a linear function, a first degree function because it has no exponents. This is a quadratic function because the exponent of 2. So we have to be careful about what we're doing and follow the directions carefully. So part A is asking us to find f plus g of x. So literally, I'm going to pick up f, which is x minus 4, and I'm going to add to it g, which is 2x squared. And I like to clean that up and put it in descending order because it's just prettier to look at. So that would be 2x squared plus x minus 4. Part B is asking me to find f minus g of 2. And normally I don't do a problem twice, but I want to make sure you recognize that you have two options here. So one way, so option 1, is to come in and find f minus g first of x. Okay, let's do that. So f is x minus 4. We're going to subtract g, which is a negative 2, which would be 2x squared. So there's f minus g of x. Now what we're going to do is come in and let x equal that 2. So now we're going to evaluate that function at 2. So if we do that, we would get 2 minus 4 minus 2 times 2 squared. Be careful here. 2 squared is 4, so that's 2 minus 4 minus 2 times 4. So that's really 2 minus 4 minus 8. It's a negative 2, negative 10 is what we're going to get out of that. Okay, so that's one way. The second way we can do this is we can come in and find each of them individually. So I can come in and plug 2 into f. So f of 2 simply is 2 minus 4, which is a negative 2. Then I can find g of 2, which is 2 times 2 squared. 2 squared is 4 times 2 is 8. And then I can subtract the 2. So now subtract. Be careful. Make sure you get it in the right order. Negative 2 because f was first in the f minus g. We're going to take that negative 2 first. Then we're going to subtract g, which is 8. And sure enough, we get negative 10. So we get the same answer either way. Just depends on which way is quicker. I tend to do the second method, especially if I haven't been forced to find that f minus g function. And to me, it's easier to plug the numbers in to begin with and then subtract versus subtracting the functions and then plugging the numbers in. Entirely up to you. Doesn't matter. Either case, you're going to get the same answer. So, negative 2, negative 10, sorry. Okay, part C, we'll show you why I think this is quicker. We're going to find f times g of negative 1. So I'm going to go the second route. So I'm going to find f of negative 1. So that would be -1 minus 4. Again, plugging -1 into x, -1 minus 4 is -5. Then I'm going to find g of -1. So that would be 2 times -1 squared. Squaring first is 2 times 1, which gives me 2. And then to find f times g of -1, I'm simply going to take those two outputs and multiply them together. So I'm going to have -5 times 2, which is going to give me -10. So part D on that problem asks us to find f divided by g of x. Well, it's easy enough to do. So we're going to take f, which is x minus 4. We're going to put it over g, which is 2x squared. There is nothing else we need to do. And because they don't give me a number, I'm done. So notice on A and D, they gave me just an x, so you don't do anything else to it. On B and C, they're asking us to evaluate that combined function at a number, so we had to plug it in. Now, part E is a little strange. It says find the domain of part A. So I'm going to get rid of part B. And then I'm going to come back in and take a look at this guy. Well, I need the domain of this guy. Well, we started with the domain of x minus 4. No radical, no x in the denominator, so its domain is all real numbers. Same thing with the 2x squared. No radical, no x in the denominator, so its domain is all real numbers. So this guy, still no radical, no x in the denominator, so its domain is the intersection of these two sets. Well, when you intersect all real numbers with all real numbers, you get all real numbers, so not very exciting. Part D, though, we have a restriction because now all of a sudden we have x in the denominator. So we're going to start off with the all real numbers, but we have to recognize that x can't be 0 because if it is 0, we end up dividing by 0. So again, we're avoiding 0 with an open circle. We can use everything to the left and the right. So the domain of the quotient function is going to go from -infinity to 0 and 0 to infinity negative. And that's how we combine functions together. And you do this a lot in the real world, especially in the business world. You guys come in and find a profit function, which is a revenue function minus a cost function. So there's a real life example of why you would need to be able to do this.